Frida, tell us about the test lab and test bed you operate.
Sure. So I operate a wireless research test bed here. It's been live and running and open to the public for about 3 years now.
Okay.
And this is actually a really exciting resource because we have a cellular base station out there, and that's an unusual resource for a university to have. It's tough to get up, it's tough to deploy, it's tough to get a license to operate, especially in New York City, which is a really crowded market. So we have this base station, and in the building directly adjacent to it, we have about 25 computers. And each of these are equipped with a cellular networking card and Wi-Fi cards, and some of them also have software radios attached to them. And this entire setup is open to the public, so any student or researcher or really anybody interested can come onto our website, reserve time on this test bed, and they can use it to try out novel application layer, transport layer, or other ideas on top of the cellular network. And they can also use it to test out novel physical layer ideas on our software radio resources. And we also use it for teaching, which is really cool, because we get undergrads who come in here and they might be taking their one and only computer networks class, and they get to do experiments involving interesting cutting-edge technologies on a cellular network. And we're also teaching a really fun software radio class. I participated last year in a competition hosted by DARPA. It's called the DARPA Spectrum Challenge. I don't know if you've heard about it. So that was,
I have now.
Okay. It was a really interesting competition. So it's kind of their first foray into wireless competitions. It was a software-defined radio competition. Teams had to implement a software radio transmitter and receiver. And then they basically set them up next to each other. So let's say I'm team A, you're team B. So our transmitters will be right next to each other, our receivers are right next to each other. They're operating on the same frequency band. And basically we fight to the death, whoever gets more data through wins. And they put all these teams against each other tournament style to see who could get the most data through in this competitive environment. And they also had an analogous cooperative competition. So we actually turned this into a course. And we teach this to students now. So we teach them wireless signal processing and software-defined radio, and then we have them get in teams and implement this and do this tournament. It's really fun.
So what are some of the variables that the teams can control to get more more data through a test bed?
So that's what's really great about software radio, because you control literally anything. So in software radio, usually a lot of things like modulation, encoding, things like that are done in hardware. And in software radio, all of that is done in software. So you write the code to do it. So basically all you're getting out of the hardware is raw samples, and you can do whatever you want with it. Now for students in a short-term project like the length of half a semester, normally the things they can play around with are, let's say, advanced techniques for signal detection, trying to detect where the other team is, synchronization, trying to hop around and get your receiver and transmitter synchronized. So these are some really tough, interesting problems that you don't usually get to tackle in a class in school. So it's really exciting that we have this test bed and these resources, and we're able to have students do that.
Now, can you actually put noise on their system, or is that against the rules?
We always reserve the right to add noise. We've never needed to, because the students pretty effectively jam each other, because you know, they're all trying to get all the data through.
So jamming is welcome, and then you have counter jamming.
Oh yeah, that's part of the strategy.
That's part of it. Okay,
Definitely.
great. And you talked about down there, you've got an antenna, you've got a smaller box, and a Wi-Fi. What cellular frequency are you transmitting on?
So this is our cellular base station across there. The cellular network is on 2.595 gigahertz. The cellular technology here is not anything especially novel. Because it's tough to get an FCC license for you know, really novel stuff. What's interesting about this is that it's fully controlled by us. So if you want to test out a novel transport layer or application layer thing for wireless, you don't usually want to do that on a commercial network, because you don't have any control over the network, you know, other traffic, the physical layer configuration. But on this base station, the researcher has full control.
Can you test any type of device on this network, or different types of wearables or Internet of Things type applications?
That's a good question. This is a WiMAX device. So we have a bunch of WiMAX phones, tablets, computers, we have USB dongles. So anything that can read from that, you can do. I actually had a student in here the other day from the Center for Urban Science and Progress. And he wants to implement something involving like waste management, Internet of Things, smart city. So he's going to come in here next week with the Raspberry Pi, and we're going to hook that up to this cellular base station, and that will act as a gateway for his waste management sensors and other stuff in this area, which should be a fun project.
Great. Well, thank you so much for your time.
Sure. Very nice to meet you.